Hey everyone, my name is Danielle Adams. I'm from New York, as our presenters told us. First of all, thank you all for having me come here. It's my first time in Sydney, and it's been a really exciting week. So actually, can we just give a round of applause to the organizers? Because if it wasn't for them, I wouldn't be here right now. And like I said, it's been a really exciting week. I had some crazy traveling. I had kind of some really great encounters. This is a kangaroo that I met, and then that's me taking a picture of myself petting a kangaroo because it was just really exciting. This is usually the part where I introduce my cat, but this was felt like this was more fitting. So I'm Danielle. This is my Twitter handle and GitHub. I actually just realized the code from this presentation isn't on GitHub yet, so don't give me like an hour after the presentation, and I will get it there. This is the world. I come from New York, a city that doesn't have as nice of wildlife. We have sewer rats and pigeons and some other stuff I won't talk about, so it's been really exciting. And I work at a company called Blue Apron, and so what I actually realized when I got here is that Blue Apron is known for subscribing or sponsoring podcasts around the world. So if that's what they're known for, but they actually do other stuff too. And that's what I work on. I work behind the scenes of Blue Apron. What it actually is okay. So this is my team. Blue Apron in the States is a company that packages prepared ingredients and ships them around the country for people to cook for their families. And the team is actually a little bit bigger than this now, but this is the kind of the original warehouse team that I worked with. And so that's what I'm going to talk about, is how we expanded our service ecosystem to include interfacing with some of the hardware that we introduced into the warehouse. So like I said before, Blue Apron, it's a startup from New York. It's been around for about 5 years. And so when I joined the team, it had a couple front-end applications and then one base Rails application that just kind of handled all of the data. If you can imagine, there's quite a bit going on. It's a monolith application. So I'm going to go back in time and talk about where we were. Now it's been 2 years, so quite a while. So a couple years ago, when we realized that we kind of had to scale because the company was growing, but also the customer base was growing a lot. And so our little monolith that we had created for all of the data that the warehouse was handling just wasn't going to cut it anymore. We had to integrate with the different hardware that we had. So you can see here, I have a scanner and a printer. We had some bigger stuff as well. So when we started realizing that these were the technical challenges that we had to tackle, some of the first questions that we had was, what should we build it in? We obviously can't do it in Ruby, which was wrong. And so my boss wanted to do it in C. Actually, he was convinced that we needed to do it in Python. I still don't understand where that came from, but I fought very hard. I was like, if we're going to do it in Python, then why don't we just do it in Ruby? Because he was convinced that Python was multi-threaded, and I was telling him it wasn't, and so it was a big thing. And so he was like, we should do it in C then. And I was like, there's no way I'm going to do that in C. So we actually, so that's fine. So this was April 2 years ago, and so we actually landed on just writing stuff in Ruby. We found that it actually would be able to handle some of the protocols that we needed, and so the hardware was speaking different protocols than what you would usually use with Ruby, which I'm going to go into a little bit later. And so actually the base reason was that there was an authentication library that we used internally that we had to support, and so that was actually the number one reason we used it, which was an okay reason, and we were moving really quickly. But it ended up being a really good decision because everyone already knew Ruby and it could support all of this functionality that we didn't know it could support. So I'm going to talk about protocols, Ruby and interfacing with machines. And then I'm also going to talk about integration with some of the services. So I don't know if I said this before, but at the time we were not only were we scaling our hardware, but we were scaling our software. So we had multiple projects going on that we were getting up and running both in as Rails applications and Ruby applications and just other stuff. Okay, so first let's talk about protocols. So what is an HTTP request? That's the request that we use mostly in a Rails application or Sinatra, any rack app that we're building in. That's usually what Ruby is known for and used for. And so how does this web server handle a request? So we have a computer, browser makes a post request or a get request from the computer. And then it goes to a DNS where it's resolved to an IP address. We have in the middle, we might have a caching layer and a load balancer. So if we have a couple instances of our application running, it will divert the message to an instance. And then in a rack, this is an example of a rack application. We have a web server, could be Puma or Unicorn. Then we have middleware. And then it goes into the code base, the web application that we built in Rails or whatever. So what is TCP? I said a little bit before that the hardware that we're supporting had to support TCP protocols. So what does that mean? TCP is the Transmission Control Protocol. It is intended for use as a highly reliable host-to-host protocol between hosts as a packet switched computer communication networks and in interconnected systems of such networks. So what does that mean? So this is the RFC that was drafted in 1981. It was originally, TCP was originally drafted to support the US Department of Defense in secure package messaging back and forth. And so, so this RFC was drafted. And so for those that don't know, an RFC is not just a standard. RFC is a document that's drafted and it's reviewed by interested parties. And so people that need to use it and have opinions, they're able to comment on it, and then a standard is built. So how is TCP different from HTTP? And so this is the kind of different levels of the protocol suite. And so the application level layer is HTTP, which is the top layer. And then the transport layer is the TCP. So we go back. So now we have a couple months later, and we started kind of prototyping with Ruby to see if we could actually use Ruby with our printers and our scanners, some of the other stuff I'm going to talk about later. So it looks something like this. So we went to the warehouses with our laptops, just like had stuff running on localhost. We're standing at the pack lines with the boxes, and we were working with associates and like telling them what to do. And so it's imagine it looks something like this. Like to imagine we've definitely upgraded from this since then. So how did we do this? So I'm going to talk about Ruby and machines. So the Ruby has a socket library, and so with that, it's standard library. Comes with Ruby when you install it, so it's not like a gem or anything. It's available, and so all you have to do is in your program just require socket, and you can create a TCP server or socket right from your application. And so socket, I've been talking about this word for those of you that don't know. The TCP provides a set of addresses or ports within each host. It's concatenated with the network and host address from the internet communication layer. This forms a socket. So if you can imagine, TCP has IP address and port. That's so like for example, localhost : 3000. It's like so you can communicate it that way. So in the Ruby library, we have a TCP socket class, and so what is this solving? And so we have a client that's like a browser. And then we needed to communicate with, so this is actually the standard version that you would do in like a web application, how we're communicating with a server that's not TCP. So we have a client, it talks to a server, it makes an update to a database, there's flow of data. But when we have a client that is talking to a server that does not handle HTTP, what does that look like? Like this printer right here. So how does that work? And so what we need to do is open a socket. In order to communicate with hardware, a TCP socket needs to be established. So it sounds kind of harder than it is, but it actually, code, it looks like this. So we require a socket library. We create an instance, and it needs an IP and a port, like we mentioned before. And we just we use the write method to write to the socket, and then we close the socket. And this is your TCP socket. That's pretty much it. So then we also have the TCP server class, and that is also available from the socket library. So again, like I said, this is the traditional flow of data when you have a web application client to server to database or some other external process. And then, so how do we communicate from a client to a server that is running on TCP? So this is an example of a Ruby script that would just create a TCP server. Again, we're just creating it locally in this instance. We choose a port. We have to keep it in a loop. So you can use while true, or you can just loop until you terminate the script. And so, so what we do here is we assign a client. When the server accepts a new client, we create a variable client. And then we get the client object, client.read. It just reads the message that it's sending. And then we close the client. So these are the types of machines that we used for, that we use the TCP libraries with. Data logic is the scanners. So we have these USB scanners, and then we also have the scanners that are hooked up to a network and have an IP address and a port. And those have TCP sockets open. The Zebra printers, stuff just like this. Oops. And IntelliGraded is the software that runs the shoe sorters that we have, which I'm also going to talk about later. And yeah, shoe sorter is just a huge piece of warehouse machine that is not interesting to look at, but it's really cool to work with. So here's a demo of just what a TCP script would look like. So going to start my server. Okay, so, and then, can you guys see this? So I could do this with RubyScript, but earlier I don't know, I messed something up and I just didn't change it. So, so I'm just gonna use netcap, which is a library. It's just like our super basic library that you can run on your computer, and it will both start a TCP server and also open a socket. So I'm gonna open a socket to localhost 8080, and then so now we have a client that has been recognized, and then I'm just gonna write a message, and that's the message we received. So now at the end of that year, we had started to move towards launching these services both within Rails applications as solo services. We're using Sinatra for to have like create a proxy to some other stuff. There's a lot of different things going on. So this is the shoe sorter that I was talking about. And so after I don't know why these stupid Pinterest things keep showing up. So the shoe sorter, this isn't Blue Apron shoe sorter, but this is a shoe sorter. So after we had kind of some of this software running, we were like, okay, how do we integrate this huge machine with our software? Because it was being built, and we were testing with it, and with the IntelliGraded software. But the IntelliGraded software also only spoke TCP, and this was a little bit unique because here, as you can see, there's something happening, and at a specific time, I guess they're shoes, I don't know. It's like the thing is coming out and it pushes it into a lane, and that is based on what at a certain point, the box is being read by the integrated software, and it knows where to push it out into a lane. So this is incredibly latency sensitive. And as you can imagine, or else you have, in our warehouses, we might have a situation where if the boxes are all diverted into the wrong lane, they end up on the wrong truck, and if you can imagine, lots of disappointed customers don't get their food, which happens. But so we need to prevent that, obviously. Not because of our software, of course. So how do we integrate with our services? So we don't want any applications to be doing too much. Like I said before, there is you have to have a server running for some things. You have to open a socket, and so when you have, for instance, if someone goes to print a label on a browser at the beginning of the pack line, we don't want to block the entire instance of the application because it's trying to connect to the printer, which for some reason somebody like turned it off or unplugged it or something like that, and then there's no printer, and then we have issues. So we have to, so we have to separate those concerns as far as like the logic goes. So I call this non-blocking integration, kind of blocking I/O. And so yeah, it's just handling that case, like I said before, where we have separate processes or instances running that we basically, like, we have some stuff that's handling web, a process that's handling socket connections, processes that are establishing socket connections that connect to the scanners, and other stuff like that. So this is an example of a problem that we needed. Like I said before, we have someone on a pack line, they have a computer in front of them, they do some, I don't know, they like click a button, and so they want a label to pop out. So how does this happen? Because browser speaks HTTP and the printer only speaks TCP, so there's a language barrier, protocol barrier. So we might do something like this. We have a browser, the browser talks to a web server. Web server could talk to a worker or an outside process. Service worker is good, or not service worker. Sidekick worker is good because the sidekick worker still has insight into the web application, but it runs independently of the web server, and then that talks to the printer. So this is some example code. Just for those of you actually that aren't familiar with Rails, there's probably a couple. But so this is the Rails controller, and it handles the incoming request from the web browser, and then it kicks off a sidekick process, or it doesn't really kick it off. It adds it to the sidekick queue, and it performs the TCP socket, it opens the socket to print it to the printer, send it to the printer. This is and then this is just the worker code. We open a socket, we write to it, and we close it. And so, and just to clarify, this is kind of, if you can imagine, it's just, like the message is just a string. So depending on the protocol or the device knows how to handle the data. And so I'm gonna go into it a little bit later, or it might be after the slide. It's just a string in our Ruby application, and that is sent, and the device knows how to handle it, whether it's some sort of hashed JSON or I don't know, some other weird message. So how do we handle scanners then? So we have a situation where we scan at the end of a pack line, and we want to update our database that we received that scan. So again, our scanner is our scanner is actually a listener to a TCP connection. Our database does not care about that. Database is doing its own protocol altogether when we make writes and updates to it. So how does it handle this? And so what we would do is we have our scanner that is connected to our TCP server. That TCP server can kick off a worker process or an independent process, and that makes an update to our database. So this is an example of some code. I created a scan daemon. It's basically just the TCP server. Daemon, for those of you that don't know, it's just a background process that does something like mailer daemon. If you, I don't know, changed your email and didn't tell anyone, it's it receives an email, and then it sends off an email to your friend that you didn't tell and says, hey, this email, your friend canceled their email, didn't tell you. So that's a background process. And so this is it. Oh, and this is the code that we wrote for it, and it's just creating a TCP server. It is able to accept a client, and then it kicks off a sidekick process, or you can fill this in with any process, and then it closes the socket to the client. So this is, yeah. Okay, so like I said before, the message is just a string, and the application reads it as just a string, but not all devices support the same protocol. So that can get really confusing because you don't want all of this crazy string stuff or like templating languages and whatnot in your application, because then like your application doesn't care that you're sending a message to a CPL. All it cares is that the barcode is right, something like that. Oh wait, that's the wrong way. And so for example, ZPL is the Zebra templating language. It's really obnoxious to write. It's just like HTML, if you can imagine, and there's a lot of just weird the characters that you have to add, and even if you forget like one character, it just won't print at all, so your printer will just completely silently fail, which is terrible. And so you have to be 100% right, or else something will be completely off, and your boxes won't end up on the right truck, and you have upset customers. So this is an example of a CPL string. At the top, it's just, this is like our opening. Can you guys see my mouse? Yeah. Okay, so at the top, there's the opening CPL characters, and there's a closing one. All these numbers are for placement, and this is for a barcode. What else? FD is for data. I don't know what the other stuff stands for, I can't remember, but that's basically, this is what it looks like. And then this is an example of a message that you would receive from a scanner, which is completely different. Yeah, it has like a date, it has some sort of identifier of the scanner, and then here's a message which you can't even really read here. I think it might start at 0. So your application does not care about any of this except for that one number. It just wants to make sure that there's something in your database that matches to this message. So, oops. So the way that we handled this was we added some middleware to our code to handle all of this logic that needs to be extracted out of the application that the application doesn't care about. So if you can imagine, we have some middleware, and so when it receives a message from a TCP socket, it kind of parses it out. It knows what it's looking for because it knows what type of device it's connected to, and it gets the message out, and then it sends it out. And the same thing going the other way. Just creates a label depending on what device it's going to. So here's my demo. Okay, so I tried to text the Australian number and it wasn't working, so I'm really sorry if that doesn't work, but the American number definitely works. So if you guys can just text your name and your title, whatever, and so it has to be like your first name, and then on the next line it has to be your title. I was really lazy with the parsing, so it's just looking for a new line, so please also try to keep it rated G. Don't send me any like dirty messages. Keep it G, and if you guys want to go ahead and text, hopefully this works. So where's our, okay. So we're gonna let this start going. I'm going to open my, oops, there's all this stuff. Oh yeah, sorry. This is the number. I should have here, I'll do a split screen. Oh, it won't let me. I capped it at 60 because I was afraid sometimes the sidekick queue gets stuck, and I was afraid that it's just going to keep going. So if by the end of the talk, if you still want a sticker and yours didn't make it, then we can just, I have like a manual thing that we can do. Okay. Oh, that's the wrong. Okay, so here's all of our people that have, thank you for participating. And so now what we're going to do is, so we have all these labels here that are printing, that were printed, got a lot of them. There's also cool little animals for, which is also cool to add to your ZPL. You can actually create a ZPL string that will output it'll print like an emoji or PNG, whatever you want. Sometimes I add like little aprons to things. Hope it doesn't break the scanners. So what am I doing again? Oh yeah, so we have printed labels. Here's my one scan label from when I was testing before. So I have a couple different stuff going on here. So here is my, actually you don't need to know about that one, so just ignore that one. This is my, this is my web server and my sidekick queue. This is the daemon that I said that we had that's been set up and it's running. And this is the, this is netcat, which is going to mock the scanner behavior from the ones that use TCP. And this one I'm just going to use the USB one because it's right here. Okay, so just gonna. I'm probably not going to do all of these, but. All right, that's enough for now. So some of these, yeah, as you can see, some of these messages came out weird. I don't know why, but most of them worked. It's good. So now let's refresh, and now we have all of our scan labels, which made updates in the database. Okay, so yeah, that's see what I mean? It just kind of goes when it wants. So some of the obstacles of, as fun as this is, it does become a little bit hard with some things. So the shoe sorter that I talked about before, so some devices don't support multi-socket connections. And so, for instance, if you have a socket or if you have two open at the same time, the device, the device won't, the device won't connect, or it won't acknowledge the message, and so it'll just drop the message, which we don't want. So we need to make sure that by we, not, I mean like people that are working on it, and the people that kind of, anyone that's working on that team. It needs to make sure that the hardware is maintaining the connections and it's receiving all the messages. And so the shoe sorter is a good example of a piece of machine that doesn't support multi-socket connections, and so we have to handle that by having dedicated processes that connect, oh my god, I might need to turn this off, that connect to the, I don't know, to connect to the server, to the hardware. So persistence. A framework might not support persistent open sockets. So for example, like I was saying before, we have our Rails application or just any web server that's running. We can't necessarily keep a socket open because it's a running process, and so it can't handle that open socket. So that's why we need that side process to handle the open socket, and then it talks back to the web server or to whatever the database or whatever. Privacy. So this one's actually kind of funny because for a bit we had, I feel bad wasting all this paper. So we need to make sure that all of our devices are on a private network, because theoretically I could be, if it's on a public domain, I could have the IP address and I could have the port, and I could just send a message from anywhere to this device, and it will, whether I'm just guessing the address or I actually know the address and I'm playing a prank on someone. So everything needs to be kept in a private network so that we are keeping our stuff secure, which is very important. And then testing. So it's really easy to forget this one because I think for me at least, I had never worked with machines before. So working with web processes, you just kind of, you can test the code. And it requires pretty minimal, just like testing from humans. I mean, it's still good to have testing from humans, but you can test a lot of your code from your, just from unit tests and whatnot. So when you start involving hardware, what happens is you have kind of external forces that take away from your, that can create a fault to your production environment. For example, if an Ethernet cable gets frayed and all of a sudden messages just stop, then you have no idea. So you need to make sure that the Ethernet cable is working. We've had an instance where messages weren't getting sent to a scanner or printer or something, and what had happened was an associate had unplugged something because they said it was too loud. So you need to anticipate. So we just lost a bunch of messages, and so you need to anticipate these types of scenarios when you're testing and when you're introducing new software like this and machines. I think that's fun with that. So I'm happy to say that we are using Ruby in our production environments. It's been over a year now, and it's working pretty well. We also introduced, so we launched the shoe sorter in one facility, and now we have it in all of our facilities actually, which is great. That was really fun to test. So this is our happy dance that everything's working, and we didn't have to use Python or Java or something else fancy. And so I guess my message to you all is that if someone tells you to use Python, don't listen to them for one. But my second is that I hope that you'll all keep in mind that using Ruby is not just a web language. It can be used for lots of things. So try it out and see what. Just gonna keep going. So try it out and just make sure that you that you can use it and experiment. And if it doesn't work, then whatever, try something else. But don't let anyone tell you you can't use Ruby.
Thank you. That's my kind of talk. For real. It was super exciting. And people could come and collect their stickers.
Yeah.
That's a way not to waste the paper. What a souvenir. If you state your name, see Danielle later.
Yeah.
It's there. That's super cool.
Also, do we have time for questions?
Oh, probably. How are we going for it?
Or not? Oh, okay.
We have got time for questions. Let's do that.
Is that associated on the ASS?
No, they're probably still there. It's just a person. I don't know who it was, but
Stuff like that happens all the time, though.
Yeah.
In our normal web world, right? That was really noisy. Those error messages are so noisy, we're going to ignore them all. Doesn't that happen? I know it happens. I personally don't ignore them, but.
We've got a question from way downtown. How do you guys did you ever encounter an endian issue? I know that some devices have different endians, and
I don't know what that
were you always passing strings?
Oh, yeah. Mm-hmm. Yeah, ish. It's stringified data. So so the sorter takes a JSON data, but you had to create it when it receives it, because it is TCP. It receives it as a string, and then it just parses that on the third-party side, the integrated side, so they know how to read it.
Was it always TCP? Were you always using TCP, or did you ever have to go down to UDP?
No, it's always TCP.
Okay.
Mm-hmm. Cool.
Anyone?
Were there specifications for all these machines to be able to know what the kind of string formats and messages were, or did you have to reverse engineer some of it?
We had to do a little bit of both. I think that, so we have, as you can imagine, this is warehouse hardware, so it's not the most sophisticated technology. So we have people that come in and they help us install whatever we need, but sometimes the machines do unexpected things, and the since it is third party, we don't really, they're not that reliable. It's just like, oh, it's broken, whatever. And then, so we had to kind of, like I think the scanner was interesting because those messages that we were receiving, sometimes it would, there was something that it was doing with one scanner where it was thumbprinting it differently, so we had to figure that out, and really, for a while, the middleware was just like reading the message wrong. So, so it's not even, this is just one brand of scanner, and then you have this another brand of scanner. So the middleware has to be able to decipher between those two brands because they send two different types of messages. So it does get a little tricky because, yeah, there's no instructions on the internet or anything. There's like very minimal ZPL documentation, which is just like PDFs on the internet, and no one has time to read all of that. So, so you just kind of figure it out.
Someone over here. Oh. 2 for 1.
Any other questions? Oh.
You can take that one.
Yes, do you keep a database with all your devices and their IPs, and you're able to ping them to get the status and the health and all that for something?
Yeah, so he asked about storing the device like data. Yeah, we do. We had an external database I don't actually remember how they were stored. I think it just might have been on like a, I think it was on like a CSV file or something, and that was living somewhere, so very sophisticated stuff. So yeah, so we had the IP addresses, and then some of them have different ports, and then also, yeah, we had to know like what type it was, what facility it's in, where in the warehouse it is. If it's, so we have much larger printers that handle shipping labels, and these are printers, or these are stickers that go on the inventory. So there's like different types of printers that have different types of outputs. So yeah, that was all, there's like a central place for that.
And you can know when they're running out of paper or something?
No, that's, you don't know. Things just stop printing, and it's left up to the associates to tell us. Sometimes that works, sometimes it doesn't.
Hi.
Hello.
Did the protocols involve some kind of security or identity management or message signing, so nobody could pretend to be a printer or send you malicious messages and manipulate your system that way?
Yeah, so all of the printers are, or all of the hardware is just on a VPN, so they can't, unless you have access to that VPN, which we had a couple services that did, they weren't able to send messages to the hardware. I think there's a couple ways that we could have handled that. There's talk of possibly moving those services to data stores within the facilities, and then we could keep kind of all of the facility stuff isolated, but that also raises the concern, well, all of these facilities are supposed to be operating the same way, so why would we isolate all of their processes like that? Because then they're all running differently and whatnot. But yeah, that was how we solved that.
I think we have a question over here.
Was there any particular online resource that helped you on your way on Ruby on hardware stuff, like figuring that out?
No. There was one blog post by DigitalOcean that taught me how to use Netcat, which is that command line thing. But other than that, it was just, I don't even think they were using TCP. They were using UDP. So just use that.
Any others? Oh, sorry, go along.
Was it difficult to get the layout of the labels printing correctly?
Yeah, as you can see, there's a lot of words that are overlapping the little like elephants and zebras, and so you have to make. It's really annoying because the places that the ZPLs are stored, you have to make some of the sizing dynamic. So you have like alpha, beta sizes, and so based on the length of the input, you have to make it smaller font, which is really annoying, but yeah, that's what we did. All right.
I've got a question. Can I
Okay.
ask a question?
Yeah.
Did you have any major catastrophic problems or anything like that? What was your biggest disaster story?
I think just in general, when the shoe sorter stops working, it's just like everything, because there's in the warehouse that I tested in, there are 10 lanes that it diverts, 9 that serve a purpose, and 10 is the jackpot. So if the thing isn't working, everything just goes to the jackpot. So when the jackpot overflows, it creates a huge, not huge, what is it? It's just like backlogged all these boxes, and it jams everything, and so that's, whenever that happens, that's really, because you don't expect it to happen, it just stops working if someone deployed some bad code or whatever. And then the warehouse is like, oh my gosh, we don't know where any of these boxes are supposed to go, and the trucks are all coming in an hour. What do we do? So that's always not great, but I think there's measures that are taken for to make sure that that doesn't become as catastrophic as it could be.
Hi.
Hey.
Do you have any tips on how to effectively read and understand RFCs?
Not really. I don't have any tips on that. I just kind of, for me, this was created way before I ever touched a computer. I think created before I was born. So I don't, when I was reading this particular RFC, I just read it for my own knowledge to make sure I understood. Because you don't want to attack anything from the side. You want to make sure you understand the full scope of what you're working with, and not having come from any sort of hardware or hardware development or anything. I wanted to make sure I knew what I was working with, and before I made this decision to to build software around these machines. So I think they were really informational. Personally, I've never commented on RFC. TBD on that.
I think maybe last question.
Yeah.
Hi. Oh, just now you mentioned that you build a TCP server, right? So when the client connect to your TCP servers, how do you handle it? Do you use thread or forks to handle the process, or you use kernel select call kind of thing?
So you mean you're asking how the?
No, when you send a TCP connection to your TCP servers, obviously you're going to read the socket, right?
Oh,
so
yeah.
When you read that, how do you process it? Whether you make a new fork, a new trace, or just a kernel select call?
Well, if the TCP server is
Thank you.
running, and what happens is the socket's established from, so it would be a scanner would be a good example of that, and so the server's just running. It handles, when it receives, it's like any server, if it receives a message, it just handles it, and so it just keeps listening, and so it's just in, it was that code that with the loop, or you could use a while true, and then you just terminate it when you need to, or you could just send it a message that says, we're done here, and it'll terminate the process. And so that's where, that could be more generic, where you're just listening to a socket, and then it has code to handle that message. In the case of my example, I was just outputting it, but you could do anything. You could use you could send an HTTP message to another service, or do whatever you want.